6 Minute English.
From BBC Learning English.
Hello, this is 6 Minute English from BBC Learning English. I'm Neil.
And I'm Georgie. That's one small step for man, one giant leap for mankind. Famous words, but do you know who said them?
Of course, that was Neil Armstrong, the first person to land on the moon.
Right. The Apollo 11 spacecraft landed Neil Armstrong on the moon on the 20th of July, 1969. But in decades after that famous event, interest in returning to the moon faded away. Until now.
Summer 2023 saw the start of a new race for the moon between Russia's Luna 25 spacecraft and India's Chandrayaan-3. Russia's rocket crashed on landing, but Chandrayaan-3 successfully touched down on the 23rd of August, making India only the fourth country to successfully land on the moon.
But why this sudden interest in going back to the moon? That's what we'll be discussing in this programme, and as usual, we'll be learning some useful new vocabulary too.
But before we blast off, I have a question for you, Georgie. Everyone knows that Neil Armstrong was the first man on the moon and was followed by a second astronaut, Buzz Aldrin. But who was the third Apollo astronaut who flew the command module while his crewmates walked on the moon? Was it A, Yuri Gagarin, B, Michael Collins, or C, Alan Shepard?
I think it was Michael Collins.
OK, Georgie, we'll find out the answer at the end of the programme. In some ways, the current interest in the moon is really more about the origins of Earth. One theory is that during the early days of the solar system, around 4 billion years ago, another planet crashed into Earth, breaking off a part which then formed the moon. Unlike the Earth's surface, which is constantly moving, the moon is completely still, frozen in time to create a perfectly preserved record of what happened at the birth of the solar system. Here's astronomer Dr. Becky Smethurst explaining more to BBC Radio 4 programme Inside Science.
Whereas on the moon, it's just this inert rock. There's no atmosphere. So every single thing that's happened to the moon in its 4.5 billion years worth of history is still recorded there on it. And so if anyone's ever seen an image of the far side of the moon, so the side of the moon that we cannot see from Earth is incredibly pockmarked. There are craters all over that thing. And so this is a really big deal when we're thinking about what happened to the early Earth as well, because we think all of the Earth's water came from impacts with comets and asteroids in the very early days of the solar system.
The rock which makes up the moon is inert. It doesn't move. It's also full of craters, large holes in the ground caused by something hitting it. The moon has so many of these craters, it's described as pockmarked, having a surface that's covered in small marks and scars.
These craters play an important part in the story. Because the moon's surface does not change, finding water there would explain a lot about how water, and therefore life, started on Earth. That's why Dr. Smethurst calls the moon mission a big deal, meaning important or significant.
That's right. Astronomers know that comets are full of ice and think comets brought water to Earth when they crashed into it. Evidence of those crashes has been erased by the constantly moving surfaces on Earth, but not on the moon. So comparing water from the moon with water on Earth could provide scientists with vital information, as Dr. Smethurst explained to BBC Radio 4's Inside Science.
Yeah, so they'll be looking essentially to see if it has the same characteristics as water here on Earth. And then we can sort of trace that back from sort of the crater history as well to working out what actually happened, how long has it been there for as well. Also various other minerals that might be there, these very heavy minerals that we know come from comets and asteroids. Again, that'll be this sort of smoking gun to be like, yes, that's where this water came from, and it's likely that Earth's water came from there as well.
Scientists can trace the existence of water on the moon back to find out what happened on Earth. If you trace something back, you discover the causes of something by investigating how it developed.
For this reason, Dr. Smethurst says finding water on the moon would be finding a smoking gun, a modern idiom meaning indisputable evidence or proof. We've learned a lot about the moon, but we still don't know the answer to your question, Neil. Who was the third Apollo astronaut on that famous first landing in 1969? I said it was Michael Collins.
Which was the correct answer. Michael Collins never set foot on the moon himself, but afterwards said the experience of looking back at Earth from the Apollo spacecraft changed his life forever. OK, let's recap the vocabulary we've learned from our trip to the moon, starting with inert, not moving or unable to move.
A crater is a very large hole in the ground.
Pockmarked means marked by small holes and scars.
If you say something is a big deal, it's important or significant in some way.
To trace something back means to discover its causes by examining how it developed.
And finally, the idiom a smoking gun refers to indisputable evidence or conclusive proof of something. Once again, our 6 minutes are up. Join us next time for more scintillating science and useful vocabulary here at 6 Minute English. Goodbye for now.
Goodbye.
6 Minute English.
From BBC Learning English.
Hello and welcome to 6 Minute English. I'm Sophie.
And I'm Neil. Sophie, did you see the beautiful sky last night?
No, I went to bed early. Why?
I was wondering if there was life out there.
You mean life on other planets? That's just science fiction, Neil.
It isn't. People are fascinated by life on other planets for a good reason.
You believe in little green men?
Not necessarily, but possibly.
Well, Mars is our closest neighbour in the solar system and the subject of today's show. And that brings me on to our usual quiz question. How long is a day on Mars? Is it about A, 5 hours, B, 25 hours, or C, 45 hours?
And I think it must be C, 45 hours. Things are weird on other planets. And Mars is further from the sun than us. Mars may be our closest neighbour, but it's hardly in our backyard, is it?
It is in astronomical terms, Neil. It's visible to the naked eye, meaning without using instruments, and it's reachable by spacecraft. Well, we'll find out later on in the show whether you got the answer right or not. Now, can you tell me, Neil, why people like you get excited about the possibility of life on Mars?
Well, Mars is similar to Earth in some important ways, which means if life developed on our planet, why not Mars?
That's true. Its temperature is in the right zone, not too hot and not too cold. But actually, we could find Mars pretty cold. An average temperature would be around minus 63 degrees Celsius compared to Earth's 14 degrees Celsius. It's also very arid or dry.
And it needs to be wet for life to develop, doesn't it?
That's right. Many scientists think that liquid water is essential for life, but there may have been water on the surface of Mars in the past, and recent research suggests that there may be water underground. Let's hear some more about this from Professor John Zarnecki, who teaches space science at the Open University.
We are now seeing that, in fact, Mars probably does have water, not liquid water. There is ice just below the surface, and there's even just recently tantalising evidence that perhaps water does flow periodically. Now, and also coupled with the fact that here on Earth we are finding that life in very primitive form exist in the most extreme environments. These are the so-called extremophiles that exist at the bottom of the ocean. So life is much, much tougher.
What does tantalising mean, Sophie?
It means something you want that's almost but not quite within reach. So, scientists would love to think water flows on Mars, but the evidence isn't strong enough for this to be certain. The other interesting point the professor makes is that life may exist in the very harsh Martian environment because primitive life exists in extreme places on Earth.
Extremophiles are organisms, or small creatures, that live in very extreme environments and can survive conditions that would kill most other organisms. But on Mars, they would be living underground because the radiation, or light and heat, from the sun would kill any organisms living on the surface of the planet. So why doesn't the sun's radiation kill us then, Sophie?
The Earth has a strong magnetic field created by its hot molten core, or centre, and this protects us from the sun's harmful solar wind.
And what about Mars? Why doesn't it have a magnetic field?
It used to, 4 billion years ago. It's possible that a massive collision with an asteroid might have heated up Mars's core, disrupting the magnetic field.
And if you disrupt a process, you stop it from continuing normally. Now, to return to the subject of collisions, Sophie, I have something very interesting to tell you.
Yes?
A meteorite, or a piece of rock from outer space, might have crashed into the Earth millions of years ago. That meteorite might have contained Martian life forms. So we might be descended from Martians.
Well, that's actually an interesting idea, Neil. But let's listen to Professor John Zarnecki talking about interplanetary life.
If we do find traces of life on Mars, we don't know, do we, whether it evolved independently or was it perhaps seeded from Earth? It is possible that life forms from Earth travelled to Mars and perhaps it existed there, or the other way around.
So, life on Mars may have evolved or developed on its own, or it might have arrived from Earth in a lump of rock, or the other way round. So, Martians might be humans, or we might be Martians. One big interplanetary happy family, Sophie.
Well, Neil, let's hope you stay happy after you hear the answer to today's quiz question. I asked, how long is a day on Mars? Is it A, 5 hours, B, 25 hours, or C, 45 hours?
And I said C, 45 hours. They must have a long day over there.
And you were wrong. The correct answer is B, because a day on Mars is slightly longer than here on Earth. It's 25 hours. Anyway, can we at least hear the words we learnt today?
They are the naked eye, arid, tantalizing, extremophiles, organisms, radiation, core, disrupt, meteorite, evolved.
Well, that's the end of today's 6-Minute English. Join us again soon. Bye-bye.
Goodbye.
6-Minute English.
From BBC Learning English.
Hello and welcome to 6-Minute English. I'm Rob.
And I'm Neil. Hello.
Hello, Neil. And what a glorious sunny day it is today. Not a cloud in the sky. Spring is definitely here. Now, Neil, you're a bit of a sun worshipper, aren't you? You like sunbathing.
I do, indeed. I love sitting in my deck chair in my garden, catching some rays.
Yes, you look a bit orange, actually. You sure that tan's not fake?
Very cheeky, Rob, very cheeky.
Now, the reason I mention sunbathing is because we're discussing the sun in this programme.
Yes, that's right. The sun is our nearest star, although it's a staggering 150 million kilometres away. Earth is one of 9 planets that orbit, or circle around, the sun, and life on Earth couldn't exist without its warmth and light.
And we should mention the sun is absolutely massive. Its volume is so large you could fit 1 million Earths inside it.
That's amazing. It's also incredibly hot. Hotter than anything you could imagine.
So, Neil, can you answer this question? How hot is the surface of the sun? Now, I'll help you out by telling you that the sun's core, that's the centre, is a blistering 5 million degrees Celsius. But how hot is the sun's surface? Is it A, 1.5 billion degrees Celsius, B, 1.5 million degrees Celsius, or C, 5,500 degrees Celsius?
I have no idea. They all sound quite warm to me, but I think it must be a bit cooler than the core, so I'm going to go for 1.5 million degrees.
OK, well, we'll find out if you're right or wrong later on. But now let's listen to Professor of Solar Physics, Louise Harrer, to discover what the sun is made of.
It's just a big ball of gas, and we measure it. It's made mostly of hydrogen, so it's roughly 90% hydrogen. It's maybe 8% helium, and the rest of it's made up of things like iron, carbon, oxygen, nickel.
So the main gas is hydrogen, which accounts for 90% of the sun's matter. Now, matter means what something is made of.
And hydrogen creates all the sun's energy. Heat and light energy is created all the time in the sun's core as a result of gas explosions or nuclear reactions. And this bit is hard to believe. It takes 100,000 years for this light energy to travel from the sun's core to the sun's surface.
But once it reaches the sun's surface, the photosphere, it can escape. In fact, it takes only 8 minutes for light energy from the sun to reach the Earth. Scientists these days are able to see the photosphere in fantastic detail using powerful telescopes.
Though Galileo observed dark spots on the sun through his telescope several hundred years ago, didn't he? Which brings us on to another question. How old is the sun?
Well, I happen to know that it came into being around 4.5 billion years ago.
Did you study solar physics at university, Neil?
No, just general knowledge there, Rob.
Well, the sun came into being, or was created, a very long time ago. We're going to hear now from Professor of Physics Yvonne Ellsworth. What does she say about how long the sun is going to stay the same?
In terms of its current lifestyle, it's here for as long again. So we're about halfway through. And then it becomes a different sort of star, it becomes a giant star, and that's probably curtains for us, actually. It'll get a bit warm, a bit toasty, and we'll get enveloped in the sun, and it won't be nice.
So, the sun is going to stay the same for another 4.5 billion years. But the professor also says that the sun will change. When it becomes a giant star, it will be curtains for our planet. And curtains means the end, I'm afraid.
Yes, it does. And as a giant star, the sun will get hotter. It will make the Earth toasty. Now, toasty usually means hot in a nice way.
That's right. For example, my toes are warm and toasty in my new slippers. But in reality, the giant sun will make the Earth unbearably hot. It will surround or envelop our planet and burn it up.
Well, I'm glad we're not going to be around when that happens. Now, remember, at the beginning of the show, I asked you how hot the sun's surface is. Is it A, 1.5 billion, B, 1.5 million, or C, 5,500 degrees Celsius?
And I said 1.5 million.
Oh, that's way too hot. I'm afraid you're wrong.
Oh.
The answer is actually 5,500 degrees Celsius. But still, if you're planning on visiting the sun, remember to take your sunglasses and plenty of sunscreen. Now, before we go, it's time to remind ourselves of some of the vocabulary that we've heard today. Neil.
Orbit. Massive. Core. Energy. Matter. Photosphere. Come into being. Curtains for something. Toasty. Envelop.
Thanks. Well, that brings us to the end of today's 6 Minute English. We hope you enjoyed today's programme. Please join us again soon. Bye-bye.
Bye.
6 Minute English.
From BBC Learning English.
Hello, this is 6 Minute English from BBC Learning English. I'm Neil.
And I'm Sam.
In this programme, we'll be discussing our closest neighbour in the solar system, the planet Mars.
Often called the Red Planet, Mars has been in the news a lot recently, with 3 separate missions being sent to explore the planet's surface in 2021.
Our fascination with the Red Planet has given birth to some interesting art over the years. This includes music, such as David Bowie's 1973 hit Life on Mars, and countless films from 1938's Mars Attacks to the 2015 blockbuster The Martian.
But human interest in Mars goes back much earlier. Ancient civilizations, like the Maya of Central America, observed the planet's colour and recorded its movements, just like modern astronomers, scientists who study the universe and the stars, planets and suns within it.
Yet, despite this, many questions remain unanswered. What caused the marks and scars on the planet's surface?
And the biggest question of all, is there life on Mars?
But before we go on, I have another question which needs answering, Sam. The ancient Romans were also interested in Mars. They even considered the planet to be a god. But god of what? Was Mars the Roman god of A, love, B, fire, or C, war?
Well, Mars is the red planet, so I guess the answer is B, the Roman god of fire.
Okay, Sam, we'll find out the answer at the end of the programme.
Whatever the Romans thought, civilizations throughout history have described looking into the night sky and seeing a bright red light. But where does Mars's characteristic colour come from?
Someone who can answer that is Dr. Michael Meyer. As lead scientist on NASA's Mars exploration program, he spent years observing and recording the red planet.
Listen to Dr. Meyer in conversation with BBC World Service programme The Forum. Try to hear the explanation he gives for Mars's unusual colour.
One of the distinctive things about Mars is that it's red, so you can see it and identify it. It looks red because of rust, iron oxide on the surface, which is red. And interestingly, that look can change. And we saw that in 2018 when there was a global dust storm. Mars, instead of looking red, looked a little orange. And it's that, that changing of color might have made the civilizations watching Mars maybe uneasy to see something immutable in our night sky changing colors.
Dr. Meyer calls Mars's red colour distinctive, easy to recognise because it's different from everything else. But did you hear why it's red in the first place, Sam?
Yes, it's red because of rust, a reddish chemical substance called iron oxide that occurs when metals react with water and air.
The colour of this rust can change slightly from red to brown to orange, and Dr. Meyer thinks these changing colours may have worried ancient astronomers who believed Mars was immutable or never changing.
Unlike ancient civilizations, modern astronomers have sent satellites to land on Mars and explore its surface. And although no human has set foot on the red planet so far, we know a lot about conditions there.
So, in the words of David Bowie, is there life on Mars?
Well, that all depends on finding water. Water is life. And as Dr. Meyer told BBC World Service's The Forum, with water, anything is possible.
And from all that we have learned from astrobiology, life is amazingly adaptable, but it still needs water. So that's why water is the key. So finding liquid water on Mars, whether or not it's now or whether or not it's in the past, tells you that you potentially have a habitable environment, some place that could support life and perhaps even Martian life.
Dr. Meyer says that life is amazingly adaptable, able to change in order to survive in new situations.
Finding liquid water could make the red planet habitable, good enough to live on. And with billionaire businessmen like Elon Musk planning manned missions to space, who knows how long it could be before we see a human on Mars?
And who knows what they'd find there? Tiny worms? Little green men? Or maybe a Roman god?
Yes. In your quiz question, you asked what Mars was the Roman god of. And I guess B, the Roman god of fire.
Which was the wrong answer, I'm afraid. In fact, the Romans considered Mars their god of war and sacrificed wild animals to him, such as wolves, bears, and, strangely, woodpeckers.
Okay, Neil, let's recap the vocabulary from this programme on the red planet, Mars, starting with astronomer, someone who studies the stars, planets and moons in our universe.
If something is distinctive, it's easily recognisable because it's different from everything else.
Rust, or iron oxide, is a red-coloured chemical that occurs when metals react with water and air.
Immutable means never changing.
Something which is adaptable can easily change to deal with new circumstances.
And finally, habitable means good enough to live in.
That's all we have time for.
Bye for now.
Goodbye.
6 Minute English.
From BBC Learning English.
Hello and welcome to 6 Minute English. I'm Rob.
And I'm Alice. Hello.
Hi there, Alice. Now, have you read any books by Jules Verne?
Yes, I have. Journey to the Centre of the Earth was my favourite book as a child. A German professor and his 2 companions climb down a volcano in search of the Earth's centre, or core. They visit strange lands inhabited by dinosaurs and giant prehistoric humans and sail across an underground ocean.
Very exciting, but it doesn't sound very realistic. How do they get out again?
Well, they shoot to the surface from the mouth of Mount Etna during a volcanic eruption.
Wow, well, that sounds very uncomfortable. Well, on today's show, we're going to discuss what scientists really know about the Earth's core.
Yes, the Earth has a dense inner core surrounded by a fluid outer core. Dense, by the way, means heavy in relation to its size. But, Rob, I've got a question for you, as usual. How big do you think the inner core is? Is it the size of A, the Moon, B, Jupiter, or C, Mars?
Right, well, I haven't a clue, to be honest, so I'm going to take a guess and say C, Mars.
Well, we'll find out later on in the show if you're right. But before we get there, let's find out a bit more about what the Earth is made of.
Well, the Earth has layers, a bit like an onion.
I like your technical language, Rob.
But I'm trying to keep things simple for you, Alice. It has a thin outer layer or crust where we live, and this includes our continents and the ocean floors. Then beneath that, there's another layer called the mantle, and beneath that is the Earth's core, over 6,000 kilometres below the surface.
Right, but what's the Earth made of, Rob?
It's a good question, and it depends on which layer you're talking about. The crust and mantle are rock and contain a lot of silicate, which is the same stuff that glass is made of. But the outer and inner parts of the core mainly consist of iron.
And the core is very hot, am I right?
You are indeed. The professor and his companions wouldn't have survived very long down there. The outer core is a swirling mass of molten or liquid metal, and it's as hot as the surface of the sun.
Wow, that must be so hot. Right, let's listen now to Simon Redfern talking about the inner core and what's happening in there.
And so over time, the planet has started to cool. And as it cools, eventually, at the centre of the Earth, the highest pressure point, we pass over the crystallization temperature, the freezing temperature of iron, and iron starts to freeze at the centre of the Earth, and you get a crystal of iron right in the middle that starts to grow.
I'm a bit worried that the Earth is freezing in the middle.
Don't worry, Alice. In this case, because of the incredibly high pressure in the core, the freezing point of iron is actually about 6,000 degrees.
Oh, right.
And the iron has been cooling down and crystallising for 1 billion years, and at a rate of just 0.5 millimetre every year.
Oh, well, yes, that sounds like slow progress.
Certainly. Now, moving on, we should also talk about the fact that it's the liquid iron outer core that generates magnetic fields. And it's thanks to these magnetic fields that life on Earth is possible.
Right.
Let's hear more about this.
Well, the magnetic field is very important because it protects us against cosmic radiation. So that's one really...
How does it do that?
It just creates a shield which will just deflect the cosmic rays from the sun to actually reach us at the surface of the Earth. So it protects us.
So it goes up there, and we're ringed
you would
by
see
a magnet.
There's just you would see the radiation kind of go round the Earth and not actually reach us.
So there's a magnetic field around the Earth that protects us from the sun's cosmic rays. I'd like a magnetic field around me. It could be my superpower, like in X-Men.
Oh, dear. Calm down, Magneto. Now, the magnetosphere is the area around the Earth in which the Earth's magnetic field is felt. It protects us from the sun's radiation and the flow of particles which would otherwise strip away or remove the Earth's atmosphere.
Right, I see. And what does radiation mean?
Well, radiation means heat or energy or particles in the form of rays, in this case, the sun's rays.
OK, and deflect?
To deflect means to make something change direction.
Right, I see. Thank you. Now, Rob, I asked you, do you remember, at the beginning of the show, how big is the Earth's inner core? Is it the size of A, the Moon, B, Jupiter, or C, Mars.
Yes, and I had a wild guess and I said C, Mars.
Yes, and I'm afraid that's wrong, Rob.
Yeah.
The answer is A, the moon. Would you like to shape up and tell us which words we learnt on the show today?
Of course, good idea. We heard core, dense, crust, mantle, silicate, molten, magnetosphere, strip away, radiation, deflect.
Yes, thank you, Rob. Well, that's the end of today's 6 Minute English. We hope you enjoyed our core vocabulary. Please join us again soon. Bye-bye.
6 Minute English.
From BBC Learning English.